Hey everyone, what's happening? Today we're doing our last transformation, so let's recap what we have. Let's pick a function like sine and see what it looks like, okay? So, let's say you have this. Okay, we're now able to talk about everything. What does the A do? Okay, so this guy, amplitude. The B, that affects the cycles. The D, this is up or down. Cool. So now, the last one was this C right here. And let's call this left or right. But just like the parabola, it's going to be in the opposite direction. Okay? And here's the thing that's so important. How much do you move? This is the question. To find out, it's actually C over B. That's how much you move. Now let me show you something very important. You may sometimes see the function written like this. Okay, so they take the B and put it on the outside. So if that's the case, oops, sorry, how much would you shift? Just C. Of course, in the opposite direction. So we have this situation where in textbooks and in Regents exams and who else knows where, you might have the B inside. We'll call that the innie. If that's how you spell innie, I have no idea. If you have an innie, you've got to take this B out of the equation. You got to kind of factor it out of there. So what you do is just say C over B. That will be your shift. Now, if it's already, how would you say outie? How about that? If you're an outie, if the B is already on the outside, then your shift is just C. There's nothing to divide. In fact, if you want to just always remember there's a 1 here, even if you did C over that thing there in front of the X, it would be a 1. So it's just like saying C. So I admit it's not a perfect world. That's the gotcha that you have to remember. If the number's on the inside, it's C over the number. If the number's on the outside, then the shift is just C. Whatever it is, it is. Okay, so let's start off by just practicing. Let's take a look at some possible functions and identify everything we know so far. Cool, so let's check it out. The amplitude, you know that that's the 2 over there. The midline, you remember, is affected by the D. That's the up and down business. So the midline is actually whatever D is, so 1. So vertical shift is up and down, right? Okay, and that's our D, so it went up 1. How many cycles? Well, there's nothing in front of that X and there's nothing outside of the X, so it's a 1. So therefore, what's my period? 2 pi over 1, which is 2 pi. Okay, so let's talk about this new thing now, the horizontal shift, left and right. What did it do? It went negative pi over 2, which we say is in the opposite direction. There's no B involved, so it is what it is. The shift is going to be right pi over 2. Amplitude. No, it's not negative. It's just 2. Midline, -5. Vertical shift, down 5. How many cycles? That's the 4. Whether the 4 is actually attached to the x inside the parentheses or the 4 is on the outside here, that's our cycles. So the cycles will be 4. The period is 2 pi over 4, or pi over 2. So in 90 degrees, this sine wave will happen completely. So that's fast. That's very fast. Okay, let's talk about horizontal shift. I know I'm going to the left because it's opposite, and there's no number in here. The number's on the outside. Okay, so it is what it is. I am going to shift left. Pi over 3. Or, that's 60 degrees. Mostly we'll see pi. Once in a blue moon, you'll get degrees. Okay, let's try another one. The next one, amplitude is 1, midline is 3, vertical shift is up 3. How many cycles? 2. What's my period? 2 pi over 2, which is just pi. Very cool. Now, horizontal, you know, the left and right business. Okay, this is in degrees because there's no such thing as 60 radians, right? I mean, there is, but let's be honest. So 60 degrees to the right, but since I have an any situation, my number, my b is on the inside, let's call that right 60 over 2, or 30 degrees. Okay, so here we just have an any. So you're going to have to get used to knowing this. If you got the number on the inside, your shift is going to be basically c divided by that number. If the number's on the outside, leave it alone. It's just a shift of whatever that is. Okay? And just as important, it's in the opposite direction of the sign. Now don't get crazy because we've seen this before. You know, the parabola, remember this guy? So f of x equals x squared. And we said, well, you know, if you put it like this, like x minus 3 squared, don't you remember that that means move to the right 3? So we would take this little parabola and say, haha, whoops, I want the parabola. Come on, give me the parabola. Ah, darn it. I'll draw a new one. Let's see if I can grab it. Ha, you're mine. Anyway, we would move it to the right 3. So this isn't the first time you've seen this. I hope you're not stressing, you know, too badly about that. It's just a trig function. It has the same rules. That's all. Okay, cool. So this is the fun part. Let's graph this stuff. Let's graph. I think I should go to full screen. Let me see if I can do that. Cool. Yeah, much better, right? Okay. Now, graphing. In this case, for this video, I'm going to do an interval of -2 pi to +2 pi. So let's go somewhere in the middle for my y-axis. And let's see. I don't have any midline changing. There's no d in this function. So I'll just set this baby up nice and in the middle. Cool. So remember when we graphed, we did the all cats play indoors, right? We have to figure out the amplitude and, you know, all that other ancillary stuff. So the amplitude here is 1. The cycles is 2. Period is 2 pi over 2, or just pi. Therefore, the intervals that I should graph would be pi over 4. Now, The next thing that's very important is this guy, this shift, right? We know it's going to go to the right, and it's going to go to the right pi over 2 divided by 2. Because when there's an any, you divide by it, right? It's going to be c over b. So it's going to be pi over 2 divided by 2. Now what does that equal? Pi over 4. So when we're done, we're going to have to go to the right by pi over 4. And let's see what happens. Okay, I'm sorry about that. I just cheated. I realized as I was counting my pi over 4s that I'd need a little more room because after all we had to go to 2 pi. And if I put 8 little tick marks so close together it would be impossible to write. So for this graph we're going to have to overshoot the runway a little bit. And I'll show you what I mean. As I mark out my counters, I'm counting by pi over 4. So this guy would be pi over 4. 2 pi over 4, which is pi over 2. 3 pi over 4, which is, you can't change, right? 4 pi over 4, there's my pi. So normally I would have just graphed that. But we want to go to 2 pi. So I'm going to have to do one more set of those. So we have 5 pi over 4. 6 pi's over 4, which is 3 pi over 2. 7 pi's over 4. And 8 pi's over 4, which is 2 pi. Okay. So on the left, we just copycat that, right? So you have negative pi over 4, negative pi over 2, and so on. So let's just finish writing those out. Perfect. Okay, 2 pi to the right, 2 pi to the left. Sorry about that mix-up. Now, we're talking about the shift left. I'm sorry, shift right, pi over 4. So when you graph the sine curve, it starts at the origin, and it goes up, down, up, down, up, down. Okay. Now, what's going to happen is this. What the shift will do is it will take your normal starting point, which would be the origin, and it's going to move that to the right. That's all it is. So I'm going to take this dot and say, okay, you're actually going to start pi over 4 to the right. So you could see that this distance here was pi over 4. So instead of starting at the origin, I took my entire graph and I slid it over to the right by pi over 4. So this becomes your new starting point. After that, it's cake. We're just going to map out all the points. So let me go back to my green pen and let's start mapping. So sine graph, if it's positive, starts northbound. And at the first interval will be at its maximum, the second interval at its midline, third interval minimum, and so on, and so on. Now we have to get all the way over here to 2 pi. Cool. Now, to the left, to that interval, we're going to be minimum, midline, maximum, midline, minimum, midline, maximum, midline, minimum. Let's see. This is pretty cool. I'm liking it. Bam, there you go. That's our sine curve. Now let me see if I could be real fancy for a second. If I mess this up, I apologize. Let me see if I can just move this sucker around real quick. Muhaha, yes I can. So look, it would have been there, starting at the origin. But since we had a shift of pi over 4 to the right, it now looks like this. That's all. Same curve, just shift it over. Let's try another graph. All amplitude, that's going to be 2. Cycles is 4. Period is 2 pi over 4, which is pi over 2. Cool. What else? Interval. Interval that I should be graphing is pi over 2 divided by 4, or pi over 2 times 1/4. Okay, it's pi over 8. Cool. The midline is 3 because I have a d, right? So the high value, I'm thinking about my y-axis right now, and the low value. So the high is going to be the midline plus the amplitude, which is 5. The low is the midline minus the amplitude, which is 1. Okay, so this whole thing's going to be north. You know, there's no negatives in here. So I feel comfortable in placing an x-axis down low, like this. And somewhere in the middle, we'll do our y-axis. We need a high of 5 and a low of 1. So let me see if I can do 1, 2, 3, 4, 5. Yeah, beautiful. This is what we'll do. I'll take every 2 is 1. So I'll do here's 1, and then 2, 3, 4, 5. This is my 5 right here. Perfect. Okay. What's my interval going to be? Pi over 8. All right, I tell you what, we're not doing it on this one. It's going to drive you crazy. This graph paper is too small for that. So let's just do one cycle in either direction. So, or pi to pi maybe. Okay, so can I get 8 lines? 1, 2, 3, 4, 5, 6. Not even. All right, let's just do one cycle, like last night's video. Sorry, Miss Sanfini. I can't go 2 pi's. On the paper you have tomorrow for your worksheet, you'll be able to. Okay, all right, so let's graph. So I need to figure out if I will be shifting, you know? So the shift, since the number is outside, is just going to be in the opposite direction, pi over 8. So my shift is going to be left pi over 8. So as I map these out, this is pi over 8, 2 pi over 8, which would be pi over 4, 3 pi's over 8, which you can't do anything with, and finally 4 pi's over 8, which would be pi over 2. On the left, you just copycat, so negative pi over 8, negative pi over 4, negative 3 pi over 8, and negative pi over 2. Now, cosine, positive, starts at the maximum, so it would normally start right here. However, we need to shift to the left pi over 8, so instead, it's going to start to the left right here. Cool. Now, where's that midline? That's very important. The midline was at 3, so 2, 3, so right here. Okay, I'm just dotting that in so I can see it. Cool. So if we're starting over here now, let's go back to green. If we're starting here, we're going to head down to the first interval at our midline, second interval at our minimum, third interval back to the midline, fourth over to the maximum. And then since we have more room to go, we'll go right down to the midline. Very cool. Moving to the left, our next interval would be at the midline, the next interval would be minimum, the next interval back to midline, and so forth. Let's connect this. Very cool. Now check it out. Again, the power of this magic pen here. This was a cosine graph, which would have started just like that, on the y-axis at the maximum. Since it was shifted to the left, pi over 8, this is what happened. It just got shifted to the left, pi over 8. How did we figure that out? We looked at the c value, which was right here. There was no number inside, so it is what it is, pi over 8. We go in the opposite direction, just like the parabola, and that's how we knew.